Thank you so much. Thank you for having me here. I'm just delighted to be here again at this wonderful Lindau gathering with you all. My point and plea today is to forge a far-sighted agenda, to develop a more global way of thinking, even a plan for science to serve our shared future, not just as individual national communities with narrow interests and viewpoints, and not just for the next few years, but broadly and for the next decades. And I think it's urgent to start thinking about this now, because as you've heard, humanity faces tough challenges. I've just got a list here. I think you can think of even more. Challenges arising out of war, such as refugees. Challenges arising out of inequality, such as unequal access to resources, education, healthcare, technology, information, the digital divide. So you young scientists here are key players. So science must play a pivotal role for addressing these challenges effectively. And I'm inspired by Marie Curie's words, because scientific knowledge brings understanding, and that understanding can guide and inform how society can meet such great global challenges as these. So let's use our scientific prowess to be more active politically and in other ways, because it's all of us here in Lindau today who are important, because we know these challenges, as has been alluded to this afternoon, these challenges require involvement of all of humanity. So for science to play a pivotal role, now's the time to ask, how can we do science better? Not just do science better, but do it better for all. And this question, I think, inspires us to consider our legacy. So my take-home for today's talk will be, I'm going to make a strong exhortation for our communities, scientific and other, to weigh in on policymakers who are sometimes recalcitrant, and they sometimes let opinions and not evidence get in the way of policy decisions. And I believe, as has been said this afternoon, and I can't reiterate enough, only a forceful expression of our scientific authority will move publics and policy makers. Now, how science relates to policies became very personal to me, because it was from the findings arising from my basic science research, pure curiosity-driven science, that I was led inexorably into the effects of social policy decision. And I'll tell you about my own story in just a moment, but I'll tell you it as an example that showed me that good policy decisions about science, globally, nationally, more local levels, can be based on good science and honest descriptions of science. And it goes without saying, because sciences, physical, biological, chemical, brain science, plant science, social sciences, etc., make it possible to base a policy decision on the question, what really is the evidence? So I'll tell you my story. My story was I grew up as a kid, one of 7 children. And that photo on the right, I'm this kind of rebellious-looking character there. And I loved the natural and beautiful world in Tasmania, which is this remote island here. I loved animals as a kid, and my curiosity about them grew into a love of science. Now, if you look closer and closer, how did living things work? Okay, under the water, in ponds and rivers and lakes throughout our planet, you can find a tiny microscopic single-celled organism. I met this one while I was doing my basic research postdoc at Yale University in the US, and it's called Tetrahymena, or also known as pond scum. It doesn't look very likely to have led to my thinking about what affects our long-term health, that is our health span, and our well-being as individuals and societies. But this was a good experimental system to study a basic science curiosity question. What's at the ends of chromosomes? Because it has tens of thousands of tiny chromosomes in this blue part of the cell here. And it was our collaborative discoveries on chromosome ends, starting in pond scum, that have led me into my conviction that our science on chromosome ends, which are called telomeres, is just one example of how science can guide and inform our approaches to at least some of the challenges of our aging and fragmented world. So how are these connected? Well, I was able to decipher the molecular structure of chromosome ends, protective DNA caps called telomeres. And telomeres are repeated DNA sequences. They cap off the chromosome ends and prevent them from fraying away. And we and many others in the past few decades have found that they can make profound differences on human aging and quality of life. And this hinges on their wearing down during our lives. Now, we're born with about 10,000 base pairs of DNA, of telomeres on average, and we have enzymes that can maintain this DNA. But often when we die of old age, they've actually dwindled down to about half of that. And this naturally occurring process over decades erodes chromosome protection, eventually causes cells to malfunction and stop dividing altogether. And now we know from a lot of research that for humans to live a long, healthy, optimal life in some ways, this dwindling down has to be somewhat counteracted. And that is because a lot of research has shown what I summarize here, which is that faster telomere shortening is associated with major common diseases and conditions of aging, many of which actually kill most of us, cardiovascular, cancers, diabetes, etc., etc. And indeed, the faster quantitatively the shortening is, the greater quantitatively is the risk in the future of getting one of these diseases, actually even risk of mortality. Furthermore, not only are shorter telomeres warning signals for disease, but also, and this is because of the cells getting malfunctional and dying off when their telomeres get dangerously short, telomere shortening also contributes to, and it's causal, at least in part, for cardiovascular disease and certain cancers, lung diseases, even dementias such as Alzheimer's, probably other diseases. And it's the science of the genetics of rare diseases and of large populations that has told us this causality. Now, a huge global challenge is aging demographics. Now, here's a timeline depicted of our life course, for example, and our goal is to improve health span. And when we ask what is loss of health span about, it's actually a lot about succumbing to the diseases outlined in the previous slide. So it's this biological process, this underlying biological process of too much telomere erosion that's one of the things, there are many others, but one of the things that helps spur on the onsets and progression and risks for these common diseases that are the major causes of loss of well-being and functionality in many situations. So it's obviously very interesting. What factors hasten these common disease burdens in our aging global demographic? Well, remarkably, loss of health span is inextricably linked to what we do individually and as a society, and we could see this quantifiably in telomere maintenance, because these factors influencing telomere maintenance in humans, as multiple replicated studies address this, these actually are linked to faster telomere shortening, and then hence, as a consequence, what I just told you in the previous slide. So these discoveries, as you can look at them, you can see they have implications for policy. Policies related to societal stress, environmental policies, including pollution. And this science really is an indication that you can see that negative policy choices that profoundly cause or affect these factors here can have cumulatively large impacts on health. So my interest in science policy was informed, and it was motivated by seeing such telomere effects on people, largely or directly as consequences of social and economic policies. And as I said, it's just one example of how foundational research can end up to quantify and provide useful, measurable kinds of evidence to guide health and social policies. And I just use my research example here just to punch home the value of open-ended discovery, basic science discovery, because curiosity-driven science, it is the engine we must support. And so telomere research and its implications inspired me to consider our global science legacy, and therefore to ask, tough question, do we do science ideally now? Let's think about this. You know, old ways of doing science really centered very heavily around competition in various ways. But let's think new ways can be much more cooperative. I mean, let's give an example of old ways, competition. For example, a lot of exclusion went on in science, and still too common in some ways. And now we can really think much more about inclusion. This means scientists within their community, and as we've heard earlier this afternoon, the very important factor, scientists interacting with other experts and other communities. And I can't emphasize enough how much it's important, humans interacting, for the progress in science and probably all arenas. And I've learned just personally, some of the most impactful science comes when you learn from others with a different outlook and experience and expertise and life history and culture. And you know, I learned this in the example of the science, my science that I told you about. So we must draw on the whole of humanity. And that means making science much more inclusive itself and in other ways. And I know we'll be discussing this during this week at Lindau. So we can all agree that to solve humanity's great challenges, I think we can agree we need all of humanity involved. And scientists mustn't be modest about their power to educate and provide evidence on which to make important decisions with global impacts. Now, what about sharing? This is, the old way of doing science. Well, it often involved not sharing with competitors. But I think we see more and more new ways of doing science where there's much more open sharing of data and discoveries. In fact, you, the young generation, you, the rising generation of scientists, I observe you do share, you do communicate using technologies that were not built into old ways of doing science. And we'll talk later in Lindau about issues of publishing, delays that causes versus rapid publishing and sharing, and that'll go in discussions during this week as well. What about resources? Well, old way of resources tended to be nationalistic, tended to be short-term, tended to be competitive, often with other countries, but we can envisage another way. We can envisage global, so sustained, more cooperative ways. And this is so crucial because science research ends up creating new products, new innovations, new impacts for health and other well-being aspects, obviously new industry, and very importantly, it ends up giving us the tools, the understanding from science, so we can deal with some of the great challenges that hit us often, seemingly out of the blue, like, climate change, like viral impact, viral, epidemics, things like that. We need science to be continuing to be able to produce the kind of understanding that if we're going to deal with these challenges effectively, we need to do it with proper scientific understanding. And the other reason to think of science in a global way is, always remember, science is not national. It's universal. Anton Chekhov here said, there's no national science, just as there is no national multiplication table, right? What's national is no longer science. Because research asking why gets to universal truth, and it's fueled by our common human interest and curiosity. And it's not directed because we don't know where it will lead. And it needs to be diverse and inclusive because of the demonstrated, through a lot of research, the demonstrated importance of diversity and inclusiveness to most effectively address complex issues. And believe me, basic science is certainly that. To address these issues in the most imaginative and innovative ways, and not merely limited groupthink. So, actually, we are collectively very cooperative and generous in our thinking when it comes to wanting to help with a short-term disaster that we can identify with. Our shared humanity motivates us, or that we can see threatens us directly too. A flood or a rapid onset of a new viral epidemic. But what remains to be done better is curiosity-driven science as the long-term engine that we must support. So we need to educate, to engage global publics as allies. Each of us in our own communities and with the use of communication technology, we will reach larger publics. And as I said, and scientists mustn't be modest about their own power. So here we are in Lindau. Can we dare to dream of new modes of supporting, maybe funding basic research long term? Well, there already exists an inspiring model, the Paris Climate Agreement. And you all know that to address an unfolding long-term disaster, over 170 more countries have signed on and become a party to the Paris Agreement on Climate, even as an intermediate step. 40 cities and states and countries have signed on to the related Price on Carbon agreement, for example. So today, I'm calling upon these same kinds of motivations that allowed these things to happen. That is, thinking proactively for a long-term shared benefit for humanity and applying these motivations then to basic research long-term. Well, it's a bold new vision, but we need to know what to aspire to have a goal that could act as a North Star. So let's see what happens when we apply a Paris Agreement-like model directly to imagining, perhaps beginning now, a LINO agreement for sustainable, globally cooperative science research resources. Right? So let's try it out. Okay, so here we have, this is the first page of the Paris Climate Agreement. Here it is. And let's just change a bit of wording here. Let's imagine it's held in Lindau, let's say 2020. Might take a little time to organize things. And it's for sustainable, globally cooperative science research resources. So I went through the agreement, the Paris Agreement, and I looked at all the wording, and it applies amazingly well. So I'm just going to walk you through a little bit. Let's try it out. Okay, so it's already agreed. Starts off, let's just adapt the wording. Welcoming the adoption of the United Nations General Assembly Resolution X, transforming our world, the 2030, because we're looking long-term, agenda for globally cooperative sustainable scientific research, and the adoption of the 2020 Lindau Action Agenda and Framework for Global Long-Term Basic Research Sustenance. Okay, it goes on. Here it is in the Paris Climate Accord Agreement. Recognizing that sustaining global long-term basic research, I just switched the words, represents an urgent and positive need for benefiting human societies and the planet, and thus requires the widest possible cooperation by all countries and their participation in an effective and appropriate international response with a view to accelerating the pace and improved quality of global long-term basic research. Okay, also recognizing, just switch the words, same phrasing. Also recognizing that deep and sustained support for global long-term basic research will be required in order to achieve the ultimate objective of our convention, and emphasizing the need for urgency in addressing sustained long-term basic research. See, this adapts very well. So let's try a bit more, right? So stay with me. Let's try out more. We'll just switch some words again. Imagine acknowledging that the shared benefits of sustained global long-term basic research are the common concern of humankind. Parties should, when taking action to ensure sustained global long-term basic research, respect, promote, and consider their respective obligations on human rights, the right to health, the rights of indigenous peoples, local communities, migrants, children, persons with disabilities and people in vulnerable situations, and the right to development, as well as gender equality, empowerment of women, and intergenerational equity. I've just excerpted a couple other things too, acknowledging that different countries, different parts of the world will need to put into this according to their capabilities. So acknowledging the specific needs and concerns of developing country parties arising from the benefits of the implementation of global long-term basic research support. And thinking about urgency, stressing the urgency of a Lindau agreement, right? But particularly recognizing the urgent need to enhance the provision of finance, technology, and capacity building support by developed country parties in a predictable manner to enable enhanced pre-2020 action by developing country parties. Okay, and then a triumph was that this Paris Agreement was adopted. So we can imagine, perhaps, this might be adopted as a Lindau agreement. We're just dreaming here on global long-term basic research, and perhaps there could even be a signing ceremony of this. So what I've done is I have outlined a provocative new idea. I've alluded to some old ways of doing science, and we will be discussing a number of these during the week. But I really think that such an international cooperative agreement, it's already started to work in the case of the Paris Climate Agreement, and for reasons very akin to the reasons to sustain long-term basic science in terms of global long-term benefit. And of course, we will need to make sure we promote facts and not be tainted with agendas, and it won't happen overnight. But perhaps we could think there might be something like this, a Lindau Agreement for internationally cooperative sustained science research support. So perhaps we could think about doing this. It'll be a work in progress. Nothing happens overnight. The road to progress is always under construction. So, to come back to what I said before, I think in order for science to benefit all of humanity, and to summarize what my main points are, we will need to focus on these critical issues facing humanity, and that's going to require long-term basic science research, because these are complex, difficult issues, and it's going to be necessary to be effective in meeting, just not in reactive mode, these kinds of big problems. And we must draw on all of humanity and broader communities, and of course share our science. So let's make this our priority, and I strongly exhort our communities, again, to weigh in on recalcitrant policy makers, bringing in all of us. So what would I say to try and get us thinking about making a difference? Well, we have to resist the temptation to feel just overwhelmed and to tune out these challenges and the news, coming in on climate change and war and inequality, but rather listen, read and learn, and vote and do something, because everybody counts. And then I want to talk, finally, you young scientists. What can you, the young scientists, the rising generation and hope that we all have, with your training and your talents, what can you bring to this dialogue? I think you can bring three things. First of all, your clear thinking. With your training and your scientific acumen, you've learned to appreciate one of the great things in science, evidence. You've learned to sift it, to scrutinize it, to use it. So use it to help those who are making policies, to help them base their policy decisions on the best evidence that you can help them critically assess. So that means share your science, speak out. Each of us, with our own communities, with use of communication technologies, we must try and reach larger publics. Scientists, as I repeat again, scientists mustn't be modest about their own power. So clear thinking, speaking, but finally, don't lose sight of the essentials. Sometimes it's simple. Learn when to trust yourself. Don't forget to listen to your heart, too, and do good science for the good of humanity. Thank you.